Welcome to another tutorial. And today we're going to make timers because we're going to make a game. Well, it's not a game, it's more like a piece of a game that's going to, uh, we're going to have this little box. When it goes through the light, a timer's going to start. And when this little character gets back in the shadow, the timer will reset. So this will show you how to make games where you can sneak around. But also it's going to teach you how to make a timer component. So let's get started. All right, so first I'm going to zoom this in here so you can see it nice and big. I'm going to move this over a little bit. So if we got this controller component here. It's just a keyboard controller. It's no big deal. I'll go over it real quick. So it's attached to the player. We got a Linux tab here. We got this component called keyboard control. So we got the two component properties under the args. We got isActive, which is an initialized bool, move speed, that's an initialized float. And you see those settings show up right here. That's the way that this is actually a this is a C-written variable in the KX Python component class, which is written in C++, I think. But you make Python calls to it. It comes with it comes with three embedded functions: start, which runs code when the game initializes, and then update, that runs code every frame of the simulation. And then there's one more built into here called dispose. And what this function does is when an object is destroyed, it runs this code. So you would use this for like an item, right? When player hits an item, the item object is destroyed, and then the dispose would be you pass data to the objects dictionary, so it accumulates items or something, right? Uh, or if a bullet hits a player, it gets destroyed, and its dispose effect is that it damages the player's HP value in its dictionary, or however you want to handle it. But we're not using this. I'm just going over the KX Python component real quick. All right. So we got the player movement, and what we want to do first is we need to create a timer component that we can reuse and stuff. And so what we could do is we could do class. We're gonna make this one be called regular timer. And it's a class that will inherit from BGE types X Python component. We'll do args is equal to isActive. And actually, isActive is a very good property to have in your args dictionary for timers, because give me a sec, my girlfriend's messaging. What do you want, woman? Okay, that's done. So isActive will have a string key of isActive with a value of initialized bool, and then we'll go ahead and have uh, time duration, and it'll be a float. Then we'll do def start with a pass, and def update with a pass. And then we will do save it. And we need to probably attach this to some text because we want it to be a text readout. So let's create an object called text. So I'm going to click on our player object with the cursor right here. And that puts the cursor right in front of the player, so we just have a good distance. And then we'll do Shift A to add an object, and we'll do text. Then we'll press R, X, and 90. And bring it up here. We need to put, since this is a dark scene, we need to put a emission on it. So we'll go ahead and do a new material. Go to emission, and we'll raise that emission to 1. Let's do 1.5. Yeah, it's pretty good. I think in my compositor, I already have a glare set up. No, I don't. Let's go ahead and add a loom node to our compositor. And we come back here and we set our compositing to camera. Now we have a little glow around our text, right? Yeah, it's pretty faint. Let's change the values on that real quick. So under compositing, go to the highlight section. We'll lower the threshold to 0.4. And yeah, that should do it. Let's see what that does. Yep, that spread it out. And now we have this white glow around it. If we want it to be more additive, we could change the color. What color should be a timer? Let's do yellow. Yellow glowing timer. There we go. Now let's go ahead and lower it more. Let's make it 0.2. And we'll raise the smoothness, and I'll spread it out more. There you go, we got glowing yellow text. All right. So let's make it a timer. So we're gonna click on the text, go to the Python tab, go add. This script is named tude16.py because I've done 16 tutorials. I think I've actually done 18, but I don't care. Tude16 dot, and this is called regular timer. And you see the options show up here, even though there's no variables or anything. So this args dictionary here is actually what the C code from KXPython makes appear here, right? And so is active. Right now the timer duration is 0. So all we have to do now is go ahead and code it. So press play, we shouldn't get any errors. So nothing's running. All right. So what we can do is you can actually use is active to turn the timer on and off. So that's kind of neat. So we can like put in if this timer is not active, reset its timer, and when it's active, start the timer, and then run the logic. So what we're gonna do is we're gonna make this text first. We're gonna make a regular like timer or a stopwatch. So So the self.isActive is equal to args is active self dot time duration is equal to args time duration. We'll save that. So what this does here is basically when we assign the variable to these dictionary key pair values, right? So isActive args is referring to this option here in the Python component panel in the engine. And then time duration equals args time duration. That assigns this float value that's here. And we can drag it and change it and everything, right? So, whatever. Leave it 0 for now. But we don't even need a duration. We just need, we're not going to be using it at all right now. We'll be using that for a countdown timer for when we do our sneak. So first we're going to make our timer. So making a timer can be a little bit counterintuitive. Like we have all these different timing values, right? Like we have print, we could do BGE dot logic dot type time. We have all these different times, right? We have get time scale. Get time scale is the multiplier between real time and simulation time. The default value is 1.0. A greater value than 1.0 means that the simulation is going faster in real time. A value lower than 1.0 means that the simulation is going slower than real time. So guess what? I think get time scale, that might be delta time built right in there. That's interesting. I'm going to have to look at that in another tutorial. And you could set the time multiplier. So yeah, that might imply it could be some kind of delta time, but we don't care about that right now. Get clock time, get the current BGE render time in seconds. The BGE render time is the simulation time corresponding to the next scene that will be rendered. So that doesn't apply. I think, yeah, you don't usually, normally you load whole blend files. You can load other scenes up, but then they need their whole set of node trees and stuff. So, yeah, I don't think that applies. Get frame time, get the current BGE frame time in seconds. The BGE frame time is the simulation time corresponding to the current call of the logic system. Generally speaking, it's what the user is interested in. And get real time, get the number of real seconds elapsed since the beginning of the simulation. These are all getters that are built into the logic, and then set clock time. Yeah, we don't want to do that. So there's actually another function we can use in the logic. It's called get logic tick rate. And we're going to print that out. So we'll run this and we'll see in our, I'm going to bring this up here. Let's make our code nice and big, right? Yeah, let's do that. Okay. Then we go ahead and reload this and run it. So our logic's tick rate is a float of 60.0, right? So what does that tell us? That's our logic tick rate. So where do we get that from in Blender? Well, if we go to the scene section here, You can set it right here under FPS. Let's try setting it to 75 and see what happens here. So you go to the Scene tab in Properties, you go to FPS and set that 75, and then you make sure you have Use Frame Rate checked. Let's turn off Vertical Sync though. Then let's run it. See, it changed to 75. So get logic tick rate corresponds to the scene's FPS, right? So this is good for a timer because what we can do, let's go ahead and set this to 60, right? Then because multiplication's faster than division, right? What we can do is in computers, right? Let's pull up our calculator. Let's do 1 second divided by 60 and see what it comes out to. So it's 0.16 repeated. So how accurate do we want our time? Now, I believe this calculator is using doubles for its float value. It's using a data type called double, which is longer than float. So, it might be a float. Yeah, it's a float. Okay. So we could just take this value, copy it. Oh, I can't copy it here. So let's do, so how accurate do we want our seconds to be is the question. So in our timer. So let's do, let's do 8 decimal points. So we'll do self dot time incrementer is equal to 0.0 to make it a float. And then our update function will do self.object. Now every text object has a value, has a property in it. They create a text object, it gets an additional property added to its dictionary called text. So you can do text. First we'll say is equal to, let's see here. What's something fun? Here, we'll honor Bucky Roberts. We'll say, hey, Haas. Okay. All right. And we'll do Alt-R, reload, and when we press play. Oh, it didn't do it. It's because I attached it to the camera. Okay. So we'll attach it to the text. There we go. Is active doesn't matter right now because I haven't set the if statement yet. Well, if we press play. Hey, Haas. Okay, cool. Now you know how to manipulate text in UPBGE. Next. So we're going to set it to self.anchor, time anchor. And it needs to be a string, so let's do string formatting. So F. And we'll put the curly braces around it. So F is a special value you put in front of a string, which is, text with quotes. And when you put in curly braces, you could say, so what we could do here is we could do time. There we go. Right now, it'll say the time is 0.0. So I save that script, and when I press play, oh, that's not it. Play. Okay, so we got the format for our timer right now. So we got that value from oh, timer was. So what we'll do now is basically after the text goes, we'll do self.timeanchor. We get into self.timeanchor plus equals 0.0 uh, 16666. Okay, let's see how many. 1, 2, 3, 4, 5, 6, 7, and 7. There we go. And then we'll now we got a timer. Okay. So that's good. Um, so we got our timer and it's going up. So and then what we can do actually is we can go ahead and compare it to the real time. So what we'll do is we'll create another text block here. We'll duplicate this one. I could compare what it is to the frame time of the simulation, see how far off we are. This only works from counting up from the beginning of the frame call. So uh, basically, when the simulation starts, the get frame time is going to be more accurate because I think it's going to go more decimal places, but we'll see. So let's do this one, and we have to pull in the object. So let's get rid of this component on the second one, and we'll bring in the object. So self dot second text is equal to self dot scene dot object. No, it's self dot objects. Yeah, self dot object dot scene dot objects. And this one is called text dot 001. We get that from right here in the outliner. Text dot 001. And then what we'll do is we'll do the incrementer has to happen at the end. We'll do self dot second text, and then it has, since it's text, it has its own text property. Text is equal to f and it'll say frame time is equal to bg.logic.get frame time. Yeah. We'll save it. We'll see how far off it is. See if we have to make our timer float longer. Yeah, pretty close. Looks like the real time is actually faster. Yeah, so over time, this timer will actually be too slow. So actually we can, yeah. Um, let's see how many decimal places we're allowed for a float. Max character length of float in Python. 24 characters. Okay, so uh we could let's go ahead and double it then. So we'll do say uh 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're worried about doing 7. I think that's throwing it off a little. All right. And we'll see how accurate it is now. Okay. So the question is why are we not using get frame time and just setting the value of get frame time for the answer to that is because we want to be able to reset the timer. Um, and also we actually need a value for it to be a variable. So, our timing occurs is the variable, so that's fine. Okay. So basically, yeah, so that's good. So that's how you make a timer. And then we'll go ahead and do an event here. So I think let's do 5 seconds. So if self dot time anchor is greater than or equal to 5.0, let's do 7.0. Then self.object dot text is equal to detected. So we will save that and reload it. And we'll go ahead and delete this guy and remove him from here and remove him from here. There we go. Okay. So we got a timer that basically when it reaches over 7, it'll say detected. So what we want to do though is We want this 7.0 to actually be our time duration, so we could change the timer depending on our design. So let's go to text here, and we'll set the time duration of 7.0 here. And then we're going to change this to greater than or equal to self dot time duration. And then we'll go ahead and press play. There we go. And then we're going to add another variable here, which is going to be, now we need to add some colliders, because what we want to do now is to make this more like a stealth game, right? We want colliders that overlap with the shadows. And whenever the player is touching those colliders, the timer will be set to 0. So we'll go ahead and do that. So let's do. Let me pause for a sec. I gotta drink something more. And I'm back. Okay. Next, we're going to go ahead and add our colliders. So I'm going to go ahead and click on our guy again here and get the distance right. We'll do Shift A. We'll do Mesh Cube. And we're actually going to raise it up because we're going to use the floor plane as part of what he's colliding with. And then we got to make sure it's the length of the shadow. So I'm going to look at it from the top here. And we'll do S to scale, X to bring it out. Something like that. And then we'll go G to move it. X to move it on the X-axis and go like that. And we need a little bit more scale here. Because the shadow on the X-axis that the player is going left to right on, actually the shadow extends out to about here. So we can extend it out a little bit more and then move it more. Go. And you see we have the shadow even casting on it. Isn't that great? So we'll go S, no, not S, G, X, move it over. So there's the start of the shadow, and we're almost close to the end. We got a little bit of overhang, so we'll scale it down again, and move it over a little bit again. All right. Then we'll do the other shadow collider. So we'll go Shift D to duplicate, press X to move along the X-axis. That's pretty close, but we got to scale it down. Scale X. GX, move it over. All right. And actually, we want him completely in the shadow before the timer stops. So we'll actually make it even smaller. Something like that. So if there's any bit of light on him, the timer will go. And we'll go ahead and do that here too. This one we just need to scale though. Scale X, bring it in a bit. Yeah, right there. Yeah, okay. All right, then for these, we actually need to go ahead and make, right now they're static, and they need to be static so the detection, collision is detected, but we got to change. We have to make him a ghost. So we're gonna select this guy, make him a ghost. Select this guy, make him a ghost. What ghost does is it basically, you know, makes it so you can walk through the collider, but the collider still detects you, right? So that's how you do area detectors. And we'll disable the sound culling. I haven't done anything with 3D sound, and I probably won't because I'm doing a 2D game right now, and I want to finish that game before I try anything 3D. Um, I'll do 3D like art for the game, but the game logic's all going to be 2D. But so we'll do 0. Then next, then what we have to do is for these colliders, we got to actually uncheck the camera icons so they don't render when the game is playing. So that one, that one, and we're going to go ahead and call this col_a. If I had a lot of colliders that did the same thing, I'd actually create a collection called shadow colliders, but run a for loop on it. But since we only got two, we're only gonna use their name. B. Okay, cool. Collider A, collider B. There we go. And then up here, we're gonna create another if statement in our update. If got to bring in the player object to the script, so we'll do self dot uh, dot player is equal to self dot object dot scene dot objects. Is this cube name player? Let's find out. Let's hide this collider for a sec. Yeah, it's called player. Okay. So we'll do player. Then we'll go ahead and bring in our two colliders. Self dot. Since they're not moving, we can make them a constant. Constants don't actually exist in Python, but the convention is that constants start with a capital letter. So we'll do call _1 is equal to uh, we should make a constant because there's dynamic stuff going on inside it. All right. And self.collider2 is equal to self. The object dot scene dot object call 2. And you know what? These actually have to be an update because their state is getting checked every frame. And so is players. So we got to put them in the update function. So we'll go ahead and do that here. So let's change this to player. Just player. Just call. And then we'll do x86. Control D to cut. And then escape and P to paste. You don't want to learn Vim or Helix. And then we'll do collision1 is equal to player.object, now player.collide with call1, collision2 is equal to player.collide call2, and we'll do if true in collision1 or true in collision2. Then self.timer anchor is equal to 0.0. So what this will do is whenever the player is in shadow, the timer goes back to 0. Once he leaves it, it starts going up again. So we'll do that. And there we go. And we gotta go ahead and they have to be visible in order to be used in the game, but we turn off their ability to render in the render view to make them disappear. All right, so now when we press play, we got an error because I gotta. Oh, it's call A. Duh. Call A, call B. There we go. All right. Now if we press play, timer should be 0. Moving around, still 0, but once we go into the light, we're going to get caught. Then back to 0. Back in the light. Going to get caught. Okay, cool. All right. So now we've created a timer with some logic, right? So what we can do now is we can lower the duration. Let's make the duration 4. So select your text, make it 4. And then now let's go ahead and add an enemy to react to it too. So we'll let's hide this. What are we going to do? First, let's duplicate this light here. Where's my light at? Lamp. Shift E to duplicate, X to move. Let's get these colliders hidden for a sec. Okay, so we got some shadow here still. And we'll turn this light down a little bit, maybe, so that shadow stays dark here. So we're going to turn this light down, just for the look of it, or lower its radius. Okay, lower its radius, lower its value. We just want to, we're going to copy our player with Shift D, go X here. I'm going to rename it to enemy. Change its color to red because there's something primal about the red color that makes people know it's mean. Oh, you got to change the material though. Okay. So it's instance and or separate the material from the instance. So it's a new material. And we change color. All right. Red and there you go. Now we got a red guy here, and we'll make him bigger so he's more threatening. So we'll scale everything and scale Z. So now we know he's a big bad guy, right? All right, bigger threat. And then we're gonna copy this text here and put it over his head. We're gonna remove the script from this one, and then we're not gonna bother with parenting or logic. We're just gonna show what you can do, and you guys can figure it out because I ain't gonna tell you everything. So we'll call this text enemy text. And we'll go ahead and bring this into the start of our timer function. Let's do this the right way. Let's go ahead and we'll go ahead and go a little object oriented on this. So what we're going to do is we'll use a messenger like a signal. So I usually don't do this, but oh well. Class text. We're going to call this player detected or detected player. I'm going to do empty args because I just want to get this done. Yeah, start. And we'll do so the starting text will be self dot object dot text is equal to question mark, and then def update now. Because text is a property in the timer, we can use that to signal the detection. So what we could do is we can do this. We could say what do we call this text here? It's just called text. Let's go ahead and call it sneak timer. And we'll do self dot sneak timer is equal self.object.scene.objects sneak timer. And then we could say if self.snacktimer is equal to detected self.object text is equal to exclamation point. And we'll go ahead and even go a little more object oriented, and we'll make this okay, so we'll go ahead and parent this text to this enemy so you can see it while he's moving. We'll go so I selected both that the enemy is the primary selections in red or orange. I press Control P, parent, set parent to object. Now it's parented. Sorry, I had to kill a fly. It's really hot today. All right. So you'll see now the text moves with the enemy. So that question mark will and exclamation point will float with the enemy. And then what we'll do is we'll go ahead and import the enemy state into this script here. Or detect player, and we'll say enemy is equal to self.object.parent. Yep. So that'll basically so that'll now get bring in the objects because this thing's the child that the script will be attached to. It'll have the logic, but it's controlling its parent. And then what we'll do next is we'll do enemy dot world position dot. Oh, let's make it even more logical. If we have to bring in the player to do this too, so we'll do that too. So player is equal to self.object.scene.objects player. Then we'll do if enemy dot world position dot x, and because he's on the right of the player, right? So we'll say if it's greater than or equal to just greater than player dot world position dot x, then self dot then we don't need then enemy dot world position dot x minus equal, we need we'll do slow speed 0.03. And we'll do an elif enemy dot world position dot x is less than player world position dot x. Enemy dot world position dot x plus equals 0.03. Okay, cool. All right, so what this is doing, it's bringing in the sneak timer. First thing it does is set the text question mark. If the sneak timer expires and becomes detected, then basically it's going to change the timer text. It's going to change the detection text over the enemy to an exclamation point, and then this will make the enemy start running at the player. So even though it doesn't have, yeah, we could put character physics on it. Let's do that. Oh, it's already got character physics. Yeah, I can do that. Normally we do walk direction. Do I have walk direction up here? I am using walk direction up here. Okay. I don't want to bother with enemy physics right now. We'll just move the object. So it'll look like he's on roller skates. All right. So now we will do our sneak. Or let's get back to camera view. And I'll go ahead and run the embedded player so you can see this in a window. Not embedded player. Let's do standalone. Did I get an error? Cool A. Oh, these got to be turned back on. Okay. Okay, we'll do standalone start, and I'll bring the window in. Yeah. All right, so our game's running now. If I go ahead and go, yeah. Oh, we got to make the camera move so we can see the enemy, huh? All right, we're going to be cheap about it, so we're going to go ahead and move the camera a little bit to the left, and then we're just going to parent. I'll do another tutorial about doing camera follow script. It's actually one of the first things I figured out, but so we'll do camera, select the camera, then we'll control click on player, and then we're going to do control P, parent to object. There we go. And we're going to go ahead and again start the game. Bring it over, and I'll go. Oh, where is he? See that far off? It's even in the game. Do I have any errors? I had no errors, so what's going on with them? See if he's disappearing from the simulation when I press play. And his text is not changing. Because I have not put the script on it. Okay. So toot16.detect player will add the component to the text object. And saying the script doesn't have it. So that means I have to resave it. Oh, and I misspelled it. It's called detect player. So I gotta correct that spelling. There we go. Detect player. Okay, then we'll go to add. Detect. Okay. There, that component's added. The other thing I'm going to do is I'm going to make this text really big. So he has a giant question mark over his head. And we'll tilt it a little bit. There you go. All right. Get back to camera view, and we will run the game in standalone start. There we got the game running. Why is he not in my game? Oh, he fell through the collider. Let's try this real quick. His gravity's reversed. What the frick? Oh, I know what's going on. So right now the texts have physics on them. We got to get rid of that. So we go to his. That's set to no collision. Sound. What's wrong with them? Ball speed's fine. That's a static ground. What's it colliding with that's causing it to go up in the air? Is the light? Let's look at his physics output. Oh, I see what I did. So that tells me it's going to run for the player automatically, which isn't good. Reload the script. Wait, what's wrong with my script here? Let's see. Sneak timer, self dot object dot. Oh, that's what it is. I have a typo. It's causing craziness. Okay. Why is it still flying up? Nothing is doing anything. Okay, we're just going to bring enemy in the regular way. I think doing this apparent is wrong. So we'll do self dot object dot. Let's just do it this way. bg dot logic dot get current scene. dot objects enemy. Okay. Then we'll do something screwy going on with this enemy. Let's unparent this real quick. Is there any scripts on him? Oh, keyboard controls on him. Okay, let's get rid of that. That's what's probably doing it. There we go. All right, now we'll try this. So, okay, let's get rid of that. Get rid of the physics visualization, and we're going to go ahead and run it in standalone. All right, game's running. Timer is 0 right now. We're in the light. The timer's going up. It's back to 0. Our big dopey enemy is like, huh? I don't see anything. Huh? But when I get in the light for more than 5 seconds, oh, you didn't detect it. I use that. But the question is, did it change to an exclamation point? Let's double check. It didn't. So what is that telling us? That detect player is not working. Oh, I know why. So we have to detect the text of the sneak timer. So if sneak timer's text is equal to detected, there we go. And then we'll go ahead and parent the text to the camera. So control click the camera. So it's under player. So control that, control click the camera, then do control P, parent object. There we go. So our big dopey red enemy is like, I'm still in the shadow, but if I'm in the light for more than 5 seconds, I'm back in the shadow. Then if I run out of the shadow for more than 5 seconds, he's coming to get me. All right, yeah, and yeah. All right, so let's go over the script, and then we should be done. So, we got a keyboard controller. You can check out the control tutorial if you want to know how it works. There's a controller tutorial. I'll link it at the end of the video. And then So what we did is we created a timer. It's basically a float value. This is based on a fixed frame rate, so we just divided our frame rate 1/60, and that way we can increment it as addition instead of dividing, because division in Python is slow. So you want to make, it's more performant if you just increment by the preprocess value. Then self-object text, there you go. We use text formatting for that time output. We created 2 collision variables that detect whether the player collides with collider 1 or collider 2. Then we check if true is in the collision variable. It returns true when there's actually collision. It actually produces a list that also, the first thing is the collision, then the second thing is actually the second value in a collision, in the collide return, is actually the coordinate vertice that you're colliding with. So that's more for like bullets to first person shooter stuff. Like, it basically tells you what the nearest vertex is on the mesh that the collision happened to, but we're only using the true. So we check if true is in collision, and then we check if true is in for those 2 colliders. And when it is, we return the timer to 0, and once there's no longer collision, the timer starts running again. And then if the timer is above our time duration, right here on the side, then it says detected. Then in our detect player, we create an object called text above it, set it to question mark at the start of the level. We brought the enemy object and the player object into the scene. We set the sneak. We went ahead and had the text. Excuse me. We brought in the sneak timer object as a variable into this script, this section of this class here. And then what we did is we checked its text value to see if it was detected. If it was, it changes the text here to this exclamation point. And then it also basically makes the enemy object that we brought in here chase the player. So there you go. If you want to make Thief the Dark project, or I don't know, a stealth game with a stealth 2D game, this is how you do it. I would make the code fancier so the logic would be, better, but this is a tutorial, so you get the bare minimum for my tutorial. So there you go. That's how you do it. So go make some stealth games and have a great day. Bye.